All right, welcome back. We are Game 3001, that's Game AI, in the winter 2020 semester at George Brown, and it's week 14. And we're talking about, for week 14's lab, and we're talking about designing AI for assignment 3. And how do we do that? All right, so a couple things. Just to start off, I have under our course, I've shared with you a new template version 9.2. Please download that from Blackboard. So I'm just going to copy this, and I'm going to put that inside of our desktop here under week 12. So under there, I've also got on Blackboard a policy matrix Excel spreadsheet. So if you can look there while I start this off. I'm also going to share this on GitHub for you. So I'm just going to pull this up quickly in VS Code so I can create a connection to GitHub. So I'm just going to say git init, git add dot, git commit, git commit -m, and I'll say initial commit. Okay. And I'll make a GitHub repo online like we normally do. So I'll go in here and I'll say GitHub, and I want to do George Brown, and we'll add a new one. We'll call this Game 3001 in the winter 2020 semester, and it's lesson 12D, because you guys are the D team. And just grab these last 2 lines of code here and go into here and paste. And that should put everything up online for you. So it's kind of a bigger project file now because I've included a couple more things, but there are no garbage files, which is good. Again, about 8 megs overall, not a crazy size. I will keep this open because later on I'll go through here and update it. And then what I can do is I can start off our template. So again, I'm using template version 9.2, and I'll talk about the template first before I start getting into the code for the AI part. Okay, but first, I want to talk about a couple things. First of all, I want to start thinking about designing your world for a second. So I'm bringing up, and you guys are a little bit behind, but I'm going to bring up Sketchbook Pro here. Can you see it, guys? Sorry, I can't really tell at this point. If you guys can see, if you can just put it in chat. I'm not recording your chat, I'm just recording my session. So can you see my screen? Excellent, thank you, Megan. There's a bit of lag from what I'm seeing here compared to what you're seeing. So what I want to do is I want to define a game world. So I'm going to kind of make it so that it's this big kind of like, rectangle. Here's my game world. Okay, let's suppose. And I'm designing I'm being your AI designer for you in some ways, right? So the first thing I want to do is map all of my obstacles. So let's suppose I want to map an obstacle that's here. Maybe I want to map an obstacle that's here. Maybe this is the enemy camp, let's say, as an example. And there might be an obstacle that's in the middle, right here, something like that. And there might be another obstacle that's over here. Let's say this is the, let me actually move that a little bit lower. Maybe this is the player area over here. Again, I mean, these are big obstacles. You could have a series of them. I've asked you for 4 for your assignment 3. Okay, so 4 obstacles minimum. And then what you want to do is think about, if I was going to walk around these obstacles as a enemy, where would I want to be able to do something where the enemy has an option to move around. So I'd probably map. This is me. I'd probably map 8 little nodes, at least, or more, that kind of allow me to map around the obstacle. This is what I would kind of do. I would say these are all the walking nodes, if you will, that allow me to walk around the obstacle. Okay, forgive me if they're not completely even. Okay, so that's the first obstacle. So again, I would have like 8 nodes that are here, 8 possible positions for my enemy to go. Again, I would do the same thing for each of the other obstacles. Now, just bear with me while I do this, and you'll see where I'm going with it in a second. So again, mapping these 8 positions here, right? Maybe another position over here and here. And the same thing goes with the other ones. So first I would say these are all the nodes that are walkable, right? And these are important considerations, because what you want to do is you want to create an area where the AI can go to. So these are all different, let's say, locations the enemy can walk, right? Again, I'm just going to map these nodes similarly, okay, every single time. So, okay. So that's the first part. The first part is I'm going to create my obstacles. Okay, notice that they're the exact same, the configuration. So think about that. Each obstacle has a list of nodes that are around it, different areas, let's suppose, right? And if you want to, you can add more, right? I'm just adding these, okay? So the different kinds of obstacles is an obstacle that is like, you know, kind of lying flat, horizontal. There's obstacles that are vertical. I mean, you can make as much or little design as you want. Again, I'm just fantasizing right now. I'm designing. So there's nothing that's actually been done yet, right? So this obstacle number 1, we'll name them. Here's obstacle number 2. And we're drawing a wireframe of the game world. That's what we're kind of doing, right? We're saying these are the obstacles in the game world. This is the position where they're going to be in, right? As an example, you are going to design your world so it's not random. You're going to design your world so that it is fixed, right? For this one, I highly recommend it. If you make it random, it'll be just way more difficult to do it that way. So here's your obstacle number 4, right? So 1, 2, 3, 4. And then what you want to do is each obstacle has a series of nodes. So these are all the nodes, right, that are walkable. Yeah? So far so good? So let's go to the next one. So now you have a bunch of patrol nodes, let's say. So not only do you have obstacle nodes, but you might have patrol nodes. So maybe the patrol node would start off somewhere on the corners, right? So I'd have a patrol node up here, another one down here, maybe another one in the corner. So every corner would have a patrol node, because you'd want your AI to be able to patrol the entire map, right? So kind of at least those areas. You can see that from that patrol node, you can go to any one of these walking nodes. That's a thing. I can also go to maybe a patrol node that's up here that's not related to the obstacle at all, right? So these are areas that I can go, that I can travel to, right? And what you can do is you can make it so that if the AI does not have line of sight, it's just going to follow kind of a circuitous route around the map. Or what it could do is it just can go to the closest nodes that I can see, you know, kind of thing, with its with its radius. And you might have some other some nodes in here too. You might have a node here, and you probably want a node in here, because these areas in here you want some kind of way of getting there, right? And you might have other ones. Okay, I'm just putting some of these. You can also, instead of using these nodes all over the place like this, you can make it so it's a tile map. So you can say, like, you know, grid and a bunch of tiles. And you can break it down so that each of the nodes are exactly in the middle of all the grids. And you can have, just like we said, you know, walkable and non-walkable tiles, just like we did in assignment 2. You could do that. Okay. Here I'm just using nodes because there's less of them than 300. I don't have 300 of these. There's way less of them. And then my AI is just going to go to each one of these locations, you know, one by one kind of stuff if it's seeking. Let's draw the enemy. So we'll draw the enemy. Let's say it starts off over here. So it went here, then it started off in the enemy camp area. So again, I'm just going to draw a circle for the enemy. There's my enemy. Let's undo that. Let's make it completely a circle. There we go. It's my enemy. And the enemy itself is on a node right now, and it has some kind of health bar. Here's my health bar, right? That shows up. And, you know, I'm going to name it enemy 1. I don't know what this enemy can do right now, but it's right over here. enemy 1. Let's make it so that the name is a little bit smaller. There we go. All right, so there's enemy 1, and we have this, right? Also, all enemies have two things that we talked about, right? They have line of sight, okay? They have line of sight, and they also have a radius. So let's make that line of sight and radius glow red, right? So now in order for me to make my line of sight and radius, let's make the radius first. So I'm going to kind of go to here and say that the radius, let's say the smell radius or the sound radius, it can hear you or see you if you're in this radius. Okay, so anything inside that radius, it can hear or it can smell, maybe it can detect you somehow other than just seeing you. Okay, and I did this on purpose so that way you have two ways of detecting the player, and if you wander around you can probably pick up the player quicker than just line of sight. That's where I wanted to go with this. Right now I want to make the player, so the player is going to be in the player area for starting off. I'll put him on top of this node. So again, here is the player. All right, and he's kind of like a little diamond. Just like the enemy, he's going to have a little health bar that kind of goes out like this, right? Player is controlled by you, so it's not like random or an enemy AI, right? Although that would be neat if you had one AI fighting the other one, but that's not the exercise here. All right, and what you want to do for the enemy is you want to draw a line of sight all the time for the enemy to the player. So this is what I would do. Okay, so again, I mean, everyone's different and everyone thinks differently, but this is my thoughts. I probably draw a line of sight that goes from the center of the enemy to the center of the player. The line of sight would literally be a line that uses a collider, a line Rect collider, which I've defined for you inside of your code already. Okay, so I'm just going to close off these things. Save. So it goes from the enemy to the player. That's what it does. Okay, enemy to player. And so how does it work? Well, it says this. It says, okay, I'm going to make a collision check between a line Rect check. We actually have that, right? And it's not going to line Rect check the player. No, right? It is always a line that's being drawn there every frame. I'm going to check this every frame. Am I colliding? Am I colliding? Am I colliding? Right? But I'm not checking to see if I'm colliding with the player. I'm checking to see if I'm colliding with obstacles. And you want to check with each obstacle that's closer to the player than the enemy is. So an example would be, okay, I want to check this obstacle. Is this closer? How about this one? Is this closer? How about this one? Is this closer? How about this one? Is this closer? Right? Well, you can see that each one in this case is closer to the player than the enemy. So I would make a list of obstacles to check, and I would check each one in every frame. So say, is this line here, this line, this main red line, right? Is it colliding with this one? No. So there's no. So this is not being. So line of sight's not being blocked by this guy. All right. Is this line of sight colliding with this one? This line, is it? Can I do a line Rect check? Does it return true with this obstacle? And the answer is yes. If it returns true with any one of these obstacles, then I don't have line of sight. Simple as that. It's either I do or I don't. If I collide with any one of these obstacles, I don't have line of sight. Is that clear? Okay, in this case. We can take this further. We can take this further if it's clear. We can say that we can also check every single node if I want to, right? So I can sit there and say, well, all right, does this one have line of sight with the player? Yes, 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 right? Yes, these are all have line of sight with the player, these nodes. But no, right? This one have no line of sight with the player. This one has no line of sight with the player, right? So there's some nodes that have line of sight and some nodes that do not. So theoretically, instead of checking with the enemy, I could just check with every single node on the board and say, do I have line of sight with the player? Yes or no? And then if the enemy is on a particular node, I can read what the node can see. Can the node see the player? Yes or no? Yes, enemy has line of sight. No, the enemy has no line of sight. Okay, so that's another way of doing it, and I recommend that this second way is the way to go. Now, there's a lot of nodes here. Let's say there's 30 nodes, and I'm doing 30 checks to see if it has line of sight, and I'm making, I'm getting a list of obstacles, and I'm checking to see if it has line of sight with the player, right? Could this be slow? I mean, there's only one player in this case, and even if there's 100 nodes, I'm checking every single frame, even 300 nodes, it doesn't matter. It won't be that slow, to be honest with you, right? We're not checking distances. We're doing a very simple line rect check, which is totally fine. There's no square root calculation here, so it's a pretty good check that you're doing. It's like doing an AABB check, which is one of the easiest checks you can make. Okay. So if I know then if each node if each node has line of sight or not, if it carries line of sight with it, if you will, then it makes my job from an AI perspective a lot easier, yeah? So let's draw another case. So this is one case where the AI does not have line of sight. Let's make sure there's another AI down here that does have line of sight. So again, I want to make another AI. So let's make it so that it's on this node, right? So again, I'm going to draw it carefully. So here's the enemy, right? And let's suppose that this is called enemy 2. And he's going to be here, all right, enemy 2. We need to do the same things that we did for the other enemy. We're going to draw the smell radius, right? So here is the smell radius. Undo. That's more of something else. Let's try that again. So let's say it's about the same size. So is the player within smell radius or hearing radius? The answer is no. I can't hear, right? However, I mean, I wouldn't hear him if he was this close, right? Let's say if the radius was this small. And again, this could be a blown up example. The radius could be quite large, that you can hear him or see him. Okay, now, do I have line of sight? So again, I'm taking from this node, not the enemy, but from the node to the middle of the player. Do I have line of sight? And the answer is yes, I do, right? Because is there any obstacle? The question to check line of sight would be, do I have, do any of these obstacles, are they closer than this enemy to the player, right? Or in another case, is this node closer to the player, right? Or is there an obstacle that's closer to the player than this node right here? Well, this seems to be around the same, right? So this kind of maybe is the same distance. So maybe this one, right? I would check. Or maybe this one, because you don't know the direction, right? I'm not checking for direction. I could do that. I could say, in this direction, is there a node, kind of thing, that's in this direction. Okay, pick that node. I could do that. I don't care about that. I'm saying anyone that's closer right now. So either this one or this one. Okay, cool. But this one here is definitely farther, obstacle 3, and obstacle 4 is definitely farther, right, than this particular node. But these ones might be closer or the same. I check to see if those two are in my way. Is 1 in my way? No. Is 2 in my way? No. So then I have line of sight. Yay, I have line of sight from here to here. Cool. So that's one thing. And if my player hits me, right, because one of the conditions is if I get hit by a player, and if this is the this is the ranged combat enemy, this maybe is a close combat enemy, but this one is ranged. He wants to keep away and fire at the player. Then I need to find the closest obstacle that has in a node, a position that has no line of sight. Okay, again, if you set up each node having line of sight or no line of sight every frame, it becomes an easy exercise, right? Then, first of all, which obstacle is the closest to me? Well, this one. So if I draw a line, let's draw another different line. So this is the obstacles that are distances. You can see that the distance between, the obstacles, that number 2 is definitely closer than all the others, right? So this is the closest obstacle to me. Cool. All right, now out of this obstacle, which node that's associated with this obstacle has no line of sight? Well, if you did it that way, then you can check to see You can check to see that, well, this one has line of sight, so I'm not going to go there. I'm not going to go here. I'm not going to go here, because these all have line of sight. This one has line of sight too, barely, but this one does not. You can see that this one is blocked, right? And this one is blocked. That's blocked. So is this one. This one's blocked. But how about this one? This one looks like it has line of sight, and so does this one, right? So all those ones have line of sight, but there's a few, right? And I'll circle them, right, that don't. There's this one, there's this one, and there's this node. These are 3 nodes that definitely don't have line of sight with the player right now at this particular frame, all right? So now, of this list, which one is the closest to my enemy? This one, all right? So guess what the enemy is going to do? He's going to move to there, right? Got it? That's how I would do it. That's how I would do move behind obstacle, or move to cover. That's how I would do move to cover. I would say, okay, which one does not have line of sight? Which one's closer? Go there. That's what I would do. Okay? In fact, if you think about it, if you think about this, you don't even care about the obstacles in this case. If you have line of sight calculations for each of these nodes, you can just say, which is the closest node to me that doesn't have line of sight? Go there. And then you're good. Right? The closest node that does not have line of sight. Closest. That means the distance. You'd have to do a distance calculation if you got hit. Okay, one time. And go to that thing. Now, I don't care about dynamically doing this. I don't care about if the player moves. It's just the last time the player hits you where you're going to go. Okay, cool. Now you have to pop out of line of sight, pop out of the cover again and back into line of sight. Okay, which is the closest node in my vicinity that has line of sight with the player, right? Well, maybe this node. So then I would move from here, instead of moving all the way down here, I'd just move from here to here. Maybe if this node has line of sight, after a certain interval, I'd move out of sight and then fire, right? And that's how I would do it, okay? In terms of moving in and out of sight, line of sight. Okay, so questions around that. So again, I have 2 enemies here. None of them are within earshot, but as an example, each of them have different situations in terms of line of sight, you know, as an example. And we can also make a third one. Let's make one more, and then we'll stop with this drawing stuff. But it's important to visualize, right? And that's why I'm doing this. I'm saying, so what if the enemy was here? So he's right kind of hugging the wall. Oops. So if the enemy was here on this node, so he's kind of behind this wall here, right? So he can't see the player. It's 100% can't see the player. But, you know, and let's give him a little health bar. So just to give him a representation of what it would look like when he's wandering around, right? We'll also give him a name, enemy 3. Right? And I don't care what kind of enemy this is. This could be one type or both, or a custom type that we talked about before, right? So this enemy number 3. And then you want to know if he's within earshot of this guy, right? So again, drawing a radius, let's just suppose that he is. So we'll contrive it so he is. So these are the 3 cases that we have, right? And there's actually one more case that we can't draw right now, right? So let's say this is like this. Approximately. He's just within earshot, okay? If we just make it the right color for you guys so you can visualize it nicer. Okay, so he's just within earshot, let's say. He can just hear him, right? They're about the same size circles. And if they're not, you can make them slightly bigger. But as an example here, this enemy, you know, does not have line of sight, because if I draw a line from this node to the player's node, right, you can see that it has an interference. It has an obstacle that's closer, and you know what? It's going to be blocked. That line is going to intersect with this obstacle, so therefore there is no line of sight, right? However, you are within a radius, so the character is within this circle, right? And the way to do that, you can do a circle-circle collision detection, where the player itself, as an example, has a bounding box, a bounding area. It could be a square, it could be a circle. I've already built those in for you. So you could basically make it so that, let's make the player's bounding area green. Kind of a darker green, right? There we go. And let's suppose that the player's bounding area is also a circle, right? And you can see that if there is an intersect between the player's bounding area and the enemy's bounding area, then he's within hearing range, which means the enemy detects them but doesn't have line of sight. Okay? Questions around this situation. I'm just creating a situation, right? A scenario, so we can start talking about how to deal with it, right? So the first thing I would do is, as an AI designer, is plot out what what my game board or the state of the game is going to look like starting off. These are 3 different possibilities. There's a 4th one where I have line of sight and I can hear the player. All right, but in this case, it doesn't really matter, right? So this guy has no line of sight, can't hear. This guy has line of sight, can't hear. This one can hear, but has no line of sight. And there might be another one that has line of sight and can't hear, like somewhere down here, let's say. Okay? 4 different possibilities. Are we good? All right, so now if this is the case, then now we can start thinking about this little matrix I put up. So I put up a matrix and I've modified it. I've started off, and if you go to Blackboard just for a second, right? So let's go, by the way, this is up online for you. If you go to Blackboard, right, and if I go to Labs, I've put it up under Lab 12, because this is the 12th lab. There is a policy matrix that you can download, right? And there's also this template version 9.2, okay, that we're going to look at today. So the policy matrix gives me some basic values, and what I've done, it's empty for you right now, and you can make it your own. But what I've done is I've gone through and renamed some of these things to make them similar to the other things. So here's my close combat enemy, all right? And think about this policy matrix as a behavior policy. That's what it is. So what am I going to do based on different considerations? So here's considerations, right? Here's a bunch of considerations, okay? And depending on the consideration, I'm going to do certain things. I'm going to make certain actions. Think about these are action states, if you will, all right? So where each state is linked to only one action, okay? We're not doing multiple actions per state, just one state, one action, okay? So here's an example. So if this consideration, player detected, right? Well, when does this trigger? Player detected triggers when either I have line of sight or I have the player within the radius. So here, player has been detected here and player has been detected in this case because the enemy can see him, line of sight, and here he can hear him. Here, player has not been detected for this enemy. Enemy number 1, player is not detected. But for enemy 2 and 3, they've been detected in different ways. Okay? So this is true. This consideration returns a Boolean that's true. So then, because player has been detected, should I move in patrol? No. I mean, my move patrol state, I'm going to start and move patrol. But my move patrol state is going to turn this to 0, right? There's a 0 chance that I'm going to continue to move patrol after I've detected the player, right? How about move seek? Well, there's a medium chance I might move seek, depending on if I can see the player or not, right? If what I want to do is move to line of sight. That's what I want to do. Well, how do I move to line of sight? Well, if I can detect the player, so what this guy is going to do, right, is does he have line of sight? So has line of sight? No. If I did have line of sight, then I wouldn't do anything, right? But because I don't have line of sight, I need to get line of sight. I need to move to line of sight, right? That's what I need to do. If I don't have line of sight and the player has been detected, then guess what I'm doing? I'm moving to line of sight. Move to line of sight would be the next action that I want to do, right? So move to line of sight means, okay, so which of these nodes, which is the closest node that has line of sight with the player, right? So let's see. Let's see, I'll just use a red line again for this, right? So does this node have line of sight with the player? Oops, I'm going to do. Let's see. So how about this one? Does this node have, it looks like it does. How about this one? That one does. How about this one? No, that doesn't have line of sight, so that's not a node. How about this one? No, that doesn't have line of sight. So it's either this one or this one. They look about the same distance. Pick one. So let's say the enemy picks to go to the closest node that has line of sight, as an example. Now, you might say, wait, that's contrived, Tom. How would the enemy know that this node has line of sight? You're right. It's contrived, right? So what you'd want to do is you want to move away from one node until, as an example, the player can also, the enemy can get a general direction of where the player is, right? Through the hearing, right? And the way it can work is we can take the player's vector and subtract it from the enemy's vector. And so I know it's kind of in this downward direction. I know he's somewhere down in here. I don't know where he is, but I need to get there somehow. So either I can go this way, right? Or I can go this way, right? So that's another way to do it if you really want to. For me, what I recommend is just report back to the enemy that this node has line of sight and move there. So it looks like it's intelligent. It's a little bit contrived, but who cares, right? So what you're going to do is kind of do one of these, move to there, right? Okay, now that the enemy has line of sight, so let's suppose it did that. So now has line of sight is true. I'm not going to move to line of sight anymore. Maybe I want to move seek if it's the close combat enemy. Move seek means I'm going to move from here all the way to the player, and so I can attack him. That's what it means. Move seek might be just move close to the player is what it means, right? So that's what it might do if I get to that point. But for the beginning, player has been detected. Well, then I want to move to line of sight. Okay. How about over here? So I have line of sight, and let's say this is the ranged combat enemy. So if I go to the ranged combat enemy here, I've just filled out a table for you and see if this works for you, if it makes sense. So if the ranged combat enemy has line of sight, then I'm going to fire at the player, right? Now I don't know if I'm in range or not. So if my distance is too far, well then I need to move to my radius. If my distance is too close, I need to move to my radius because I want to be within a specific radius of the player. I don't want to go too far out. So example, in this case, he's too far. Maybe his range of maybe he's a shotgun, and the range of his weapon only goes up to this radius. So he's going to move closer. Now notice that there is no node here, and there's no node in some places. But that's okay, because remember that the enemy can move close to the player with steering behaviors. He can move here, even though he's and he can maintain line of sight here. If you want to, again, you can put additional nodes throughout the game, so that it makes it easier for him to know where to move to, right? So example, you could put a node, if you really want to, in different spots, like maybe a node here, maybe if I can draw a node instead of a line, maybe a node here, maybe there's another node there, whatever, right? You can draw additional things, or you can have a grid, whatever. But if you draw that, and if you move to this next node, he's going to be definitely within there, but you want to be able to kind of be within or keep him away from this radius, right? So then fire would be the next thing. Can I fire at him? Yes. Let's say I'm not too far anymore. Then if I'm not too far anymore, then I want to I have line of sight and I'm not too far, then fire. That's what that is, right? Okay, so if the player is within radius, then basically move. If I need to move within radius, move to a radius if I need to. Otherwise, maintain line of sight, move to line of sight. And I'm already at line of sight. If I'm already in line of sight, I don't need to move. This would be 0 if I'm already in line of sight, because has line of sight would 0 this part out, see? Because you have these two conditions. If I'm within radius and I have line of sight, then I'm not going to move to line of sight. It's going to 0 that part out, okay? Okay, then the enemy gets hit. The player fires a bullet at the enemy gets hit. Now, if the enemy's been hit, then I'm not going to patrol, that's for sure. I'm not going to stay. Moving to radius has nothing to do with it. Moving behind cover, though, that's really high. That's a really important thing. The rest is not as important. So I need to find behind cover. I'm going to find the closest node that has no line of sight, like I said before. And so I'm going to move to this node most likely, right here. So let's just draw that node. So I'm going to move to a spot that I can see, right? That is the closest spot. So I'm going to move from here all the way to here, because this node here has no line of sight. This node here, okay? That's a bad circle, but that's you get what I'm saying. I'm going to move over here, okay? So that's this. If the enemy's been hit, okay, cool. Then when I'm there, I have a random interval behind cover. It's passed. So let's say I've waited X number of frames behind cover. I'm going to pop back out. So I want to move to line of sight. Move to line of sight. Okay, so going back, I was here. I want to move to the closest point that has line of sight. That's this one. So again, I move from here. I move to here, and then I fire at the player. Right, that's what I want to do. And I want to move to the closest point that has line of sight and is within distance of the player. If the player is too distant, then I have to move closer. Maybe I have to move, instead of this one, maybe this node doesn't qualify, maybe I have to move to this one. Okay, maybe that might be close enough so that the player's within radius, so I can fire my weapon. Okay? So that's how this chart works. The chart is basically a behavior table. The behavior table is gonna tell the player what to do, right? Tell your enemy what to do, what not to do. Okay, and each enemy is going to have this behavior table, and it's just a behavior table is literally just a matrix of action states and considerations. All right, where considerations are rows, in this case, and action states are columns. So row column format, almost like a two-dimensional matrix, right? That you can make. Okay, so if you made this a two-dimensional array, then you can say that action state move patrol and player detected is 0, 0. That's the 0, 0 location, right? Similar to what we talked about today with the Q matrix, right? Very similar, except the enemy's not going to learn. The enemy's literally going to use these hard-coded values to make decisions with, right? They're going to say, okay, well, if my player is detected and I'm in move patrol, do I continue being in move patrol? No. So that's not going to be the action I'm going to take next. All right. If my player is detected and my distance is not too far from the player, or I'm too far from the player, then maybe I need to move to the line of sight. As an example, player's been detected. I want to move to the line of sight. That's going to be my next action. Okay, I have line of sight and I can fire my weapon. Well, you know what? Fire at the player. That's the next possible action. And you're going to choose that based on this, behavior table. And you're going to combine actions. You're going to say, okay, I want to move. Here's the considerations. Combine the result, the utility of each action state. I'm going to combine them to get a value, and whatever that value is, right? I'm going to take that action, the highest, the action state with the highest value. Okay. So that's the way I'm thinking about it from a design perspective. Are you guys good? Yes? No? Need more explanation? I can't tell, guys, because I'm not seeing any kind of response in the chat. I'm going to assume you guys are good. All right, so that's our behavior table. Our behavior table looks just like this. All right. Now, I have an idea of what I want to do. I have kind of an idea of my behavior table, and I got the behavior table by looking at this. And last week, I kind of talked about triggers and conditions, and I kind of derived my behavior table from this. I'm calling it a policy matrix, but really at the end of the day, it's just a behavior table, right? I've got these actions and triggers. And depending on the trigger, I want to do certain actions. Okay. I'm going to keep this up though. I'm going to keep this table up because we're going to get back to it in a bit. All right. So now let's take a look at the template that I kind of built for you guys. So let's take a look at this. So I'm going to double click on my template solution. So 12D, which is built off of template version 9.2. So I made a couple of additional things here that we need to talk about in template version 9.2. Right. I was asked by a group of students outside of this class. They said, listen, I need buttons to work with your templates. I have buttons that was shown by Alex, but my buttons don't work exactly on your template. I don't want to use I am GUI. How do I do it? Kind of thing. So I made some buttons, and that's the first thing I'll show you. So the way it works now, if I was going to run this thing, right, I've got a couple buttons for you, so you can use them on your game or on your if you need to use buttons at all. But there's a technology that I'm going to use with the buttons again today. I'm going to kind of reuse some of the stuff that I did with the buttons, and I will show you this in a sec when this thing launches. So if you run template version 9.2, the reason why it's 9.2 is I made slight modifications to 9. I didn't make it 10 because I don't think it's worthy of a template 10. That's just me. But here's what I got. I got this start and restart button. And notice if I hover over it with my mouse, it kind of is it's accurate in terms of where I hover. Hovering over is an event, okay, that I've created. Okay, they both work, and they basically just change the alpha transparency to 50%. Okay. If I click on start, I can go to my animation. I can run my animation like we did last time, no problem, right? Similarly, if I run this again and click restart, I made a restart button. It doesn't matter, right? I could have called it go to the end scene. But if I click the restart button, it goes to the end scene, okay? And also notice that I have, from a memory management perspective, which is important, I'm just going to kind of go here and show you this. We'll just minimize this. You can see that the memory usage is still fairly small. If I press 1, it'll take me to the, that pathfinding scene we had before with the mines and all that, right? And remember that I can move around my planet all kinds of ways, and it'll add a little bit of memory to it, but not a great deal, right? Not a great amount, which is a good thing, right? And then if I shift out of this scene to the start scene, it kind of drops again. You see that little bit of a drop? This is a good thing. So memory doesn't really explode anymore, right? But I'm back to here again, right? So I can go here, and I can go back and forth, and these buttons all work. Okay, so that's how these buttons work. And you might say, well, who cares, Tom? That doesn't seem like anything. You're right, 9.1, 9.2, it's not a big deal. However, let's talk about the technology I had to fix. One thing was, there was a bug. So one of the students here in your course found a bug with my code. They said, Tom, I have a problem with the animator, right? So animations before the animation class only had a friendly string name and a vector of frames, right? So I would say, well, this animation called the idle animation has these 4 frames, frame 0, 1, 2, 3, as an example, right? And then instead of having the current frame inside of the animation, I had it as part of the character. So for example, I had it under my player. Player itself would have a little frame, current frame. Well, this was okay if my player's 2 animations, in this case, Mega Man had 2 little animations, an idle animation and a run animation, and both of them were the exact same length, 4 and 4. So it didn't really matter. But what about if the animations were different length? Then what happened is the current frame would go from 0, 1, 2, 3, 4, but there's only 2 animations, let's say, in the other animation. It would fail. It would crash out, right? Because it would have a null reference error, right? And I didn't want that. So we had to include the current frame inside of the animation. So for my player CPP now, it's slightly different. Instead of it using the built-in current frame of the player, it just uses the animation's idle current frame. In another iteration of this, if I was going to refactor this, I wouldn't even have to pass this as a parameter because I'm already passing in animations, so I don't have to do this again. Okay, I can actually just deal with this inside of the texture manager play animation function. Once I have this, I can just call the current frame, and I wouldn't have to pass it in at all. Okay, if that makes any sense. And I'm going to get better and better at making these a little tighter as we go. It's just not going to happen this semester. Okay, maybe during your physics class. All right, so that is the little change I made to this. Now, how did I do the buttons? Remember, Alex kind of had defined these little button callbacks, right? So he made buttons that work with a callback. Here's my button. My button is very similar to what Alex does, except I do a couple things. I include an unordered map, and I also have something called event.h, right? And event.h defines a bunch of events. Let me just talk about what those are. So go to definition. So I've defined a few events that I want to track. My buttons really respond to mouse clicks right now. So they respond to a click, a mouse over, and a mouse out. By the way, this click is only for left click. I could have left click, right click, double click. I can do a bunch of stuff. I've only defined these 3 events. Okay, but you can define whatever events you want. Okay, here. So in my, if these are just enumerations, right? So if I go back to my button, what I did was I defined a function pointer. So that's what this is. So this is a function pointer definition. So what is that? What is a function pointer? Well, imagine that I want to have different functions that are associated with each different event type. Example, my click event might have a click button click event, button click handler, whatever that is, right? I might also have a mouse over or mouse out handler, right? And I want them to be associated with the particular event. And I don't want to define what that handler is because every implementation of the button class is going to be slightly different. For example, maybe in some buttons, I want the alpha transparency to be 50%, like I showed. Maybe other buttons, I want to swap out the texture, just like Alex does, and give you a different kinds of states for the buttons. Let's say an over state and an out state, where I swap out the texture and make it look different. So that would be a different implementation for that particular button. And I wanted to give the flexibility of the user to have whatever he wanted or she wanted. So I made this event handler function pointer, and I used typedef. And what typedef does in C++ is it creates a small little type. It says that, hey, you know what, let's use this event handler as a little macro to say that I can use the event handler keyword as a function pointer. So example here in add event listener, which is my function. By the way, add event listener, I stole this from JavaScript because they call it add event listener, right? And C# does the same thing. But I could use this keyword or these kind of a function name add event listener, and I want to take two things, an event and an event handler. Here's my event handler, right? So two things that I'm getting here, right? If that makes sense. Okay. So because I've got these two things, my add event listener then, if I go to definition, it does this. It takes an event, so it could be a click event, a mouse over event, mouse out event. And my event handler is the callback function. It's a pointer to a function. So this function takes a function as a parameter. I don't know what function it's going to be, but it's a function that has to take a button pointer as a parameter. A function that takes a button pointer as a parameter. Okay, that's what it does. And that's what this handler is. It's a callback. That's what it is. And a callback function is just another function. So when I'm done, when I've detected the event, right, then I'm going to trigger this function to fire, if you will. So when I add event listener, what I'm really doing is I'm registering this event inside of the event map. That's what I'm doing. So inside the button.h down on the bottom, I have another unordered map where it has the enumeration for the event and then the callback function, the event handler, whatever it is. Okay. I don't know what this function is going to, what it's pointing to right now, but whatever it's pointing to, this event is going to be pointing to that particular function, right? Okay. So I map the event to the function. So handler is going to be stored inside of the map, so I can always go back to that. Okay, that's the add event listener. I also have a little helper function to check to see if this event already exists. I don't want to register more than one event because I'll have a memory leak, like I did with the texture manager, right? So I'll say, hey, does the event already exist? If it does, well, return false. Don't even do this in registration. If it doesn't, right? If it doesn't exist, then add this new thing. One thing that's missing from this thing, this event system that I've got here, is a remove event listener. I should be able to remove an event listener from from the map. Here I'm only adding them. I can only ever register them. I can't unregister. And here what we're also doing is we're using this idea of an observer pattern, where each function that has registered with this, as an example, for that set of events can get a response. Okay, almost like a notification that, hey, the event has triggered. Okay, so yeah, so this is the add event listener thing, and I have a handle mouse events function that's here inside of the button, and the handle mouse events function, and again, I probably could have written this as a singleton. All the handle events functions can point to a singleton, like an event manager or something like that. I haven't done that here in this version of my code. But what it does is says this: I have SDL mouse motion, so it detects mouse motion. If my mouse motion is detected, I call this point rect check. So this is a new thing that I've added to the collision manager. So point rect check says, hey, take this point as an example, and I need a rect start and a rect width and height. That's what I do. And then I check to see if this point, which is the mouse pointer, right, the mouse location, X and Y, is inside of this rectangle. And if it is, well, then I want to return true. If it's not, then return false. That's what it's going to do. So that's what point rect check does. Okay. So going back to the button.cpp then, I say, hey, if using my collision manager, my point rect check is true for my button and my mouse position, then guess what? Set this Boolean that I've set up, mouse over to true. Could I have done this with states? Yes. I could have used a state machine here too. Didn't do it. Okay, I just made Booleans for this one. All right. So mouse over is true. Otherwise, mouse over is false. If I'm not colliding, then I'm not over the mouse. My mouse is not over the button. That's pretty much what I'm saying here. Okay. So that's the SDL mouse motion. Now, there's a couple things. I have two events that I could register. One is the mouse over event. And if I've registered that event, then I want to say that if mouse over and my mouse over event is not already active, because if it's already active, I don't want to register another hit on that event. I only want to have that event trigger once when I'm mouse overing, right? So it's a single trigger. It's not going to keep showing that I'm over. I'm only going to show it once, right? When I'm over the first time. After that, the only time it's going to show it again is when I'm back over it. Otherwise, it's going to be too much noise. I'm listening too often, right? So it's only going to do it once this way. And then I check to see if my mouse is over the button. If it's true, then call the function that's associated with the mouse over event. So that's what this does. So call function that is associated with the mouse over event, whatever that is, whatever that function is. And I pass in a reference to this. Passing in a reference to this is passing in a reference to this button because it needs a button pointer at the very minimum. Okay? Cool? So, and then I set my mouse over active to true, which means I only want to check this if it's not already being checked. I'm not already over the button. In this case, I am already over the button, which means the next time I come around in my next frame, I'm not going to do this again. I'm only going to do it once. I do the same thing for mouse out, except it's the other way around. I check to see if I'm already mouse out active and I'm not over the button. So it does the exact same thing. I call the function that's associated with the mouse out event here. That's what I'm doing. So whatever that function is. Okay, so that's mouse over and mouse out, and that happens over SDL mouse motion. However, what about if I'm clicking the button down? If I'm clicking the button down, some button's being clicked down, and it's the left button, so I'm only doing it for the left mouse button. If I've registered the click event and I'm over the mouse is over the button, that's what this means, then again, just like I did before, I have a little Boolean that says mouse button clicked is true, right? And I'm going to call the click event, whatever is related to the click event. Call the click event handler. Whatever that event handler is. I don't know what it is. I'm going to register it later. Remember, I'm going to register a bunch of events, and whatever that is, I'm going to click it. Okay? So that is really how the mouse button works, okay, in terms of things. So there's two parts that can make it challenging to look at. One is this part right here. This idea of a function definition of a function pointer. All right, that's what it is. This function definition of a function pointer. I could have made a function, an event handler class, right? And that would be its own type. Here I'm not making a class or a struct, right? All I'm doing is making a little function pointer that I'm creating a really quick function for, a really quick definition for, a type that only is applicable to this class, so the button class. So this type, event handler, is not available outside of the button class. It's only available inside the button class. Okay? Okay, cool. And I have a couple of utility functions. I can set alpha and set active. I can set the button active or inactive. I can disable it or whatever. That's what this does. Okay? So that's cool. How do I implement this now in my scene? So if I go to solution and if I go to the start scene, so if I go to scenes, I'm just going to collapse these for now. If I go scene, start scene, so start scene, I include the button. That's what I'm doing here. And then I have two buttons, pointers that I define. Start button, and I called it second start button. Who cares, right? I could have called it restart button, which is what it is. And then what I did was, if I go to the start function, you can see that I define some labels, and then I come down to defining some buttons. And this is the second confusion piece that I've coded. All right. So I make some memory for the button. I set the button's position, and then I use add event listener, and I say, okay, I'm going to register the click event, and I want to use, what the heck is this? I want to use a Lambda expression to point to an anonymous function that's going to trigger whenever I click this event. This is an anonymous function, so I'm not using a named function anymore. A named function being a function with the name. I'm using this inline function. And I'm doing this by using something called a Lambda expression. The first part of the Lambda expression, these square brackets, is really the capture part. Think about this part as the name function in JavaScript, if you took JavaScript before. Okay? And the second part of this Lambda expression is what I'm passing into the Lambda expression as a parameter. Notice here I'm passing in a button as a parameter, right? Just like I needed to do inside of the button class. The button class also needs a button pointer as a parameter. Okay? So that's what this part of the Lambda expression does. Then this arrow says, what does it return? It returns void, which is exactly what the button event handler returns. Void. It returns void. Okay? So it has to match the return type for it to work. Okay, cool. And then in the curly brackets, this is the scope of what I'm doing. If the click event is true, I'm going to automatically trigger the code that's inside these brackets to work, or these curly braces, as if this is a function that's being called somewhere else. Okay, so I click this and I execute these two lines of code. I set the button active to false, and then I move from this scene to the next scene, to level 1 scene. That's what this works. I do the same thing with my mouse over event and my mouse out event, except this time I use the button pointer to point to the button itself. That's what it points to. And I can set alpha transparency on the button to 50% and here to 100% when I'm either mouse over or mouse out. That's how it works. Then I add the button to the display list. Add child adds the button to the display list, which actually takes care of updating and drawing each of the buttons. Cool. And I do the same thing with my next button, but the difference is I use a different texture for the button, the restart button texture. I could have used whatever I wanted, but I wanted to use this one. And for the most part, the mouse over and the mouse out event, I could have used a named function, because for mouse over and mouse out, guess what? They're the exact same, right? The only difference being that the button that they refer to is different buttons. But for the most part, I could have made a named function so that this event handler points to a named function instead of using this anonymous structure here with a lambda, right? But these ones are different. The click event is always different, right? The click event does something different for every button. So here, this click event, it moved me to the level 1 scene, but this click event here, it moved me to the end scene. Okay, that's the difference between one button and the other. Okay. So I'm giving you this as a gift because if you can do this, you can make whatever event you want. You can make it use Lambda expressions. I'm just giving you examples of how to use Lambda expressions. You can also make it use named functions. It's up to you how you want to make it work. Or you can choose not to use this template at all and just fix your animator, and you can go back to using what you had before in version 9.1. It's up to you. But this is just a little, that's why it's a little increment of what I did. Questions around a couple things. Questions around your function pointer, that's what this is, and questions around Lambda expressions. Anybody? Are you guys clear with all that stuff? I can't see the update, guys, so I don't know if you want to. If I don't see a kind of a message in chat, then I don't know if you guys are okay. I'm going to assume that you're okay, though. So 50-50, Hardik. So what does that mean, Hardik? You want to talk about it a little bit more, or do you not? What don't you get? Because 50-50 means like you kind of get it, but you kind of don't get it. What is it? What are you having trouble with? And Megan too, if you want to kind of describe what you're having trouble with. You'll watch the video again. Okay, no problem. No problem. All right, so that's what this does. So the event handler literally does it's just a function pointer. A function pointer is like in other languages, for example, in C#, it's called a delegate. That's what it's called. And think about what a delegate is. It's like a person to stand for you, right? So if I'm your delegate and I want to go to some government office, I represent you. That's what it does, right? So here, this function pointer represents the actual function, but it's actually not the function. I can point to different functions that I want this thing to call, right? I'm going to use this same syntax again for our AI stuff in a second when I link actions to our action states. Okay, so I'm going to talk about this. And that's why I kind of brought it into being as well. All right, let's continue. So now that we've talked about our little setup and what we've done differently, let's start adding our classes. And I'm going to refer back to the book. So if you go back to the book's details here, I'm looking at state machines. So again, it's chapter 5 in the book, and it talks about state machines and how to do the pseudocode. It talks about the state machine class. This is the pseudocode from the book, as well as the state class. Mine's going to be slightly different than this. And the transition class they talk about, as well as a condition class and a flow condition and so on. I'm going to start with the condition class instead of the state class. But I'm not going to call it condition because I want to use utility AI. I want to call it consideration. Now you can call it condition because you don't have to use utility AI. You literally just have to say, if this condition is this, then do that. That's really what you have to do in your AI, your enemy, right? So let's do it. So I'm going to go back to my code and I'm going to add some structure. Now you don't have to do it this way. This is the way my fever brain works, right? So I sit there and say, well, you know what? I would like to have a new class. I want to put this inside of my source files. A new interface actually is what this is. I'm going to call this new interface consideration. And the consideration interface is like a condition, right, for a particular context. So again, when you make anything new, you're going to say if not defined. Then I'm going to define consideration. So define it. Okay. Oh, bad at typing today. Okay, so that's that one. And I'm going to make a new class. It's going to be called consideration. Okay, I'm going to have a public and a private area. And my consideration, I want to make it an abstract class. That's what I want to make it. Remember what I need to make for an abstract class? I have to have at least one abstract function. So pure virtual is what I have to make. And or I have to make my constructor a pure virtual or a virtual constructor, right? So I need those two things. So I'm going to make my my destructor. My constructor is going to be like this. My destructor is going to be virtual, right? And I'll make it a pure virtual on top of that. Memory management is better. Okay. And I want, if you look at the book tells us we need this function to test. A function that tests and that returns a bool. Notice that we're using this arrow to return a bool. This is just pseudocode. So I want to return a bool. So I'm going to say that I want a boolean. This is going to be called test, right? The test function. And I'm going to return, it's going to be a pure virtual. So I'm going to say virtual bool test. So this is a abstract function. And this is an abstract class. This is a pure virtual destructor. Okay? Do we make sense so far? Yeah? Because I'm making this a just like a single file like this, I'm going to make it so that I set up the constructor function in one, right? So consideration is not going to have really a definition for the constructor, right? I'm just going to make it so that when you include consideration or you extend consideration, you get this test function out of it. Now in the book, they also talk about a different kind of consideration. You can have a float condition or you can have something else. So let's take a look at the float condition. So a float condition, and again, I'm just replacing condition with consideration for me. It's the same thing, but it has two things. It has a min value and a max value. We can set the test value for my that we want to test with, right? And then what we can say is in the test itself, we can override the test function so that returns if the test value lies between the min value and the max value. That's what we want to do with the float condition. So let's make that as a float consideration. Okay, so again, I'm going to go back to my Solution Explorer and I'm going to go to, by the way, consideration shouldn't be here. Let's make a new filter. So I'm going to add a new item. Oh, no, a new, I'll be good. New filter. And let's call this filter, you know, kind of, we can call it AI, we can call it decision making. Let's just call it AI. So my AI filter, okay. We can move this anywhere we want, right? Like outside of there, like in here. Nope, let's undo that. Arg. Sorry, I'm trying to make it so that it is right. Darn it. Let's just get rid of it and do it again. Visual Studio. New filter, AI. There we go. Here's my AI filter. Sure, it'll be at the bottom. I don't care. All right, so my AI filter, that's where I want to put my considerations. So I'm going to take my consideration out of my headers file into my AI. There we go. All right, and inside the AI, I'm going to also add another one. I'm going to say add a new item. We're going to call this a float consideration. So float consideration as we're building this up. And we're going to say, if not defined, float consideration. Then I want to define float consideration. Okay, and this one, of course, is going to inherit from consideration. So I'm going to say class float consideration extends a public consideration superclass. Oh, wow. Consideratione. And you can see that it says, hey, include it. I will. Here's my consideration superclass that it includes. So float consideration is going to be like, it's going to have a public area and a private area. And I'm going to have a couple of private instance variables. One of them is float m underscore min value. And another one is going to be a float m underscore max value. Okay. I'm also going to have the test value, whatever that is. Okay. So those are the three things. When I use my constructor function, I want to take in, you know, when I create this stuff, right, I could set up my min value and my max value. So I can say that the min value and the max value is whatever, right? So float min value, float max value. Hey, let's even add in the test value, float test value. Right? I could do that. Test values between min value and max value. That's what I'm really saying, right? And what I want to do here is also define some minimum values. So I can say like the minimum value, well, that's 0. And I can make zeros for all of them. So I can say that this is 0, This is 0, so give it a default value. So I could start off with nothing if I want. I can just make it a float. I can make a float consideration with nothing in it if I don't want to, right? And then let's make a float consideration destructor, right? There's my float consideration destructor, right? And I also want a couple of getters and setters. So getters and setters. So one of them is set test value. So again, void set test value, which is going to be some kind of float that I want to test other than the one I've already defined. So set my test value to value, right? I also want to, a couple other ones, I want to set my min value. So maybe I want to set that min value to something else. And also set my max value. So give myself some flexibility. Okay, I could get getters for this too. I'm not going to make getters because this is really a test that I'm doing, a testing between two values, right? So I also want to include the overrided function. Which one is it? I need to generate missing members. Generate missing members, which is going to generate my virtual bool test override function. And now that I've got this, I'm going to go here and generate definitions by declarations. But I need to do that inside of a CPP file, which I haven't defined yet. So let's do that. Solutions, make, add, new item. In my CPP, we're going to call this float consideration. And I'm going to include here float consideration.h, which is going to trigger me when I go back here and go to generate definitions by declarations. It's going to generate all that inside the file. Immediately I'm going to make, for now, the constructor default, or the destructor default. And I also want to use initializer syntax to say that m underscore min value is equal to min value, as well as m underscore max value is equal to max value, and then m underscore test value is equal to test value. Okay, so I want to do all those. Okay. And here it says, hey, why don't you make this const? So I don't think that's a bad idea to make these const. I don't think they should change. I think it's a good safety check for a constructor to do. Okay, so that's kind of what it does there. All right. Why is it telling me that? It's not actually true anymore. Okay, so that's one, and then that went away. Okay, good. And then my set test value, I want to say that m underscore test value is equal to value. M underscore min value is equal to value. These are just setters, right? And then m underscore max value is equal to value. So I can set them outside the function, right? Outside of this class. And I can set all these to const, right? Because it makes sense. So I'm just having access to set them. I can't read from them, but I can set them right now. So a write only function. And this bool function, this test, is going to return if it's true that my m underscore min value is less than or equal to my m underscore test value, and if my m underscore test value is less than or equal to m underscore max value. So that's how I can write this, similar to what we have in the book. Okay, so that kind of is the condition that returns true or false. So I can test those two values, whatever the values are. So example, I can set a value, a range of values that I want to check. I want to check that the player, the distance for the player is between, again, the distance from, as an example, the obstacle or whatever is between 10 and 40 pixels. If it's between 10 and 40 pixels, maybe I want to trigger something. Okay, that's what this is. That's what this float consideration does. It creates a range of values. Okay, if that makes any sense. Okay, a float consideration can be pretty flexible too. For example, the min value. What if you made the min value and the max value the same? Right. So what you could say is, let's suppose that I say, if the min value and the max value were the same, and I said that, let's say the max value was something I want to compare. Let's say my test value was the player's health, right? And my player's health was, let's say, 50 points or 49 points. And my maximum value is 100. So I can say that, hey, is my test value, let's say, 0.49 less than or equal to my max value, which is 1. So that's right side would work, right? Okay, what about if the max value was also the min value? So 1, is that less than or equal to test value? The answer would be no, right? So this one works. So you'd have something like a less than. This is like a consideration that compares two values, and if it's in the middle between these two values. That's what the float consideration does. But you can make other kinds of considerations. One that's a bool, one that's a min, one that's max, less than or greater than. Different comparisons that you can create, so that when you create these comparisons, you're comparing one thing to the other thing. Okay? So that's the consideration class that you can use. All right? And in the book, they say, well, what if you have more than one consideration? For example, I have a consideration and another one. I want to test them both, and they both must be true in order for me to have a true state. So I can have an AND condition and or an AND consideration where I can have both those two things work. All right? Or I can have an OR consideration where I have either one or the other consideration to happen. So I can have these little helper classes. Another way to do this, instead of doing it this way, would be to use template classes, right? So I can use templates. So going back to my code here, instead of making the consideration class, this class here, instead of making this consideration class an abstract class, I can make this a template class, right? And the template class would take, maybe I would have different values in here, right? So whatever the value would be. So let's say, for example, it could be Boolean, a Boolean value that I want in here, or it could be, you know, a float value that I have in here, or something else I want to test with, right? And that test value is going to be either a bool or a float, and then I can check to see if my float is a minimum or a maximum, and I can do all kinds of stuff here in the template class. All right. I could also include comparison operators, right? So I can say that the template class, or the class consideration itself, has two static functions. One is a static function that does AND or add. I want to AND two things together, right? Another static function that does OR and NOT. I can do that. So I can say, are these two considerations, are they, as an example, are these two both true, right? Then I can return this function. I can just pass in two considerations. So the way to do that would be whatever the consideration superclass would be. So consideration dot, I wouldn't instantiate something. It would be a class that I could use. Consideration dot, and it would public static. So I could write it something like this. So public static, and I can call this option, it would return, as an example, Boolean, public static Boolean that would say, it would be called and I would take two considerations. So I would say consideration, right? I would pass in a consideration. It would be the left-hand side, right? So consideration 1, and then a consideration, the right-hand side, right? I'll take those two considerations in, right? Now notice what it says here. It says that class consideration is abstract, and because it's a pure virtual, I can't do this because I can't point this in. And even if there were consideration, unless there were consideration pointers, and if there are consideration pointers, then I'm not instantiating a consideration. I'm just kind of passing in a reference to these two considerations, and I can do an AND kind of operation. Let's do one more. So let's suppose that I did an OR, right? And I can do the same thing. I can pass in two considerations, the left-hand side and the right-hand side. And then this way, I can compare one to the other, right? Depending on what the test value is. So the way you would code this out, if I was doing it, let's just code it out really quickly. This is what you could do. And again, I'm saying could a lot. And by the way, I wouldn't want to do it inline like this. I'd want to make it so that consideration has a CPP. Let's just undo that. I mean, I could, but I just prefer a CPP, so I'll make another new item. We'll call this consideration.cpp, and then we'll move on. Okay. There we go. Let's try that again now. So I want to, and then if we're going to have a CPP, then I might as well just do a, I might as well do a constructor in the CPP as well. So then I'll just go here and say generate definitions by declarations, which will generate everything. And in the consideration, the virtual consideration here, I'll make it so that it is, I don't have to do anything there. I can get rid of this piece. It's not important. But the constructor function itself would be pretty much empty. I can make that default as well. It's not going to do anything. However, with these considerations, and the test also would be something that would be empty, right? I'm not going to make it, I'm not going to define the test. That would also be a pure virtual, right? So I can do that. But these two I'd want to define, right? And I can say that if, so return, right? Like it said in the book, consideration, so left-hand side, test, right? If that's true, and right-hand side, test, if that's true. Okay, so that's going to return true. And for the OR, I could just put an OR instead. So, oops, which would look like a double pipe character. All right. So that's the OR and the AND, right? And what I could do to make that work is I could say my consideration class and the delimiter : and, right? And then put two considerations there, and it can return if it's true or not. So and OR, and not would be the other one. I'm not going to do not, but you get the idea. So I can, instead of, I can save myself you know, 3 classes here by just using these as a static function that's part of the consideration superclass. Okay? So that's something we've done before. Okay? That's something we've seen before with vectors. We've done, well, we've done actual other classes like this, but yeah. So that's the consideration. So then we've got the consideration building blocks. Let's make the state building block. So I'm going to kind of do that. New item, and make it do .h. We're going to make a couple of things here. So state .h, and immediately I'm going to make the state.cpp. Add new item, state. So I'm going to include state, right? And also what I'd like to have in here is a state action. So a state action, or an action state, if you will. But the state action probably makes more sense. An action that's related to the state. So we'll call it state action. Well, actually, might be better to be called action state. And I'll put this inside the enums folder. So we'll say action state. So add a new item. It'll be a .h. And we'll call this the action state. Let's start with this. So I'll say that if not defined action state, then define it. Right. And then end if. And it's going to be an enum. It's going to be called action state. And my action state enum is going to have the following states. I'm going to look at the action states that I have here. I'm going to start off move patrol. Okay, let's try that. So move patrol. That's going to be an action state. And then I'm going to have move seek. Move seek. And then I'm going to have move melee attack. Sure, melee attack. I might move these around a little bit. And then I'm going to have move flee. Okay. Move flee. Put that there. And then move to line of sight. That's a good one. Move to line of sight. Okay, move to LOS, line of sight. So I've got all these. These are all the state or action states, if you will. All right, how about for the ranged enemy? They're kind of similar. Move patrol. I don't have a move seek, but I have a move to radius. So so move seek. Let's have a move to radius. Move to radius. Actually, maybe let's put the move twos together. So move to line of sight. Move to radius. Let's say, okay. Move behind cover. Okay, move seek. Move flee. This is kind of like move behind cover. You could also maybe make this a move to cover, right? Move to line of sight, move flee, fire at player. That's kind of a ranged attack. Let's call it ranged attack. Ranged attack. Okay, and then maybe something like no action. Like I'm not taking an action, so I no action state. Starting off, I have no action state or a null state. Okay, so that's this, and maybe at the end, a number of action states. So just to keep track of how many, you can see that I have 9 right now. And that's all I would need, right? That's 9 action states that I would have for my entire game, right? For each of my enemies can share some of these. And notice that like I said before, my my close combat enemy could have player detected, has line of sight, distance too far, as an example, as well as player within radius. These are all the same, and even player health less than 50 or enemy health less than 50 is the same. So these 5 are the same as these here, right? So I have this, there's a lot of the same, right? And this one, these are all the same, but these two are different. These two are different, and this one is different, because here we care about player health, here we don't. Okay? So that's the only difference that we have between these two things. So these are all the action states, if it makes sense, okay? And now that we have this, then in my state.h, when I define this, let's define it. So again, it's if not defined, state, then define state, and then end if. Okay, so I did that. And in my state.cpp, I've included it, which is good. I'm going to say that the class is called state. Okay. I'm also probably going to make this an abstract superclass. All right. I don't have to, but let's just think about making this an abstract class, right? So how do we do that? Well, we need to make it a public and a private area. In my state, right, I want to call the state constructor and a virtual state destructor that is also a pure virtual, right? So there's my state constructor and state destructor, pure virtual, and a couple things I want to have here from my state class is this idea of utility. Now I'm going to use utility. You can use value. You can use whatever the particular state you have is. There'd be a higher value for one state over another state, whatever that is. And also a state is going to have an associated action. So first off, we should have an action state, right? And it's going to be called m_action state. All right, so we need to include action state.h, right? Needs to have that, as well as some kind of callback function, as an example, that is associated with that state, right? A callback, an action that's associated with that state. Now I'm going to borrow from my my button class for me to do that. Remember I did this whole idea with the button class when I had this function pointer? Well, I could do the same thing. Instead of making a function pointer like this is only defined here. I can do the same thing in my state in here and define it in here. Instead of making it an event handler, I won't call it event handler. I'll call it action. And I won't listen for anything else, just the action itself. So what this is going to be is a function pointer definition for the action function, whatever that is. Okay, so that's what that definition is. And what I can say is that each state has an associated action. Okay, so something that it points to. Of course, I want to make it so that I can set action, right? Or and also perform action. So those are the two, we'll say, getters and setters. So I'm going to say set action. So set action, whatever the action is associated with this state, I can set it. And I can say that it's a new action type. Okay, set action. As well as perform action. So perform action, whatever the action is, I'm going to perform it. Okay, so far so good. I should be able to also set the state by default. When I set the action state itself, whatever this thing is, I should be able to set the action state inside here. So I'll say that action state m_action state, and actually we'll say action state, and we'll say by default it is no action state, so that you don't get anything by default. So it has a default setting if I need to. So that's one thing that constructor will do, either take an action state or none. Okay, I also want to set an action state. So let's say void set action state. So I can configure it without the constructor is what this is doing. So action state. Okay, so those are things I want to do. And then of course I have utility, so the value of this thing altogether from my my state class. So in my state I could have a utility. So it's going to be a floating point value called m_utility. And remember what utility is? I talked about utility AI last week. It could also be known as a value for you. But think about it as a number that means something in terms of how much priority does this action have, this state action have over another one. Going back to our behavior table then, it would be like, well, if my player has line of sight as an example, and I maybe I want to move seek. Move seek might be high. It might be like a 1. So that my utility for move seek might be a higher utility than move patrol or move melee attack or move flee or move to a line of sight. Move to line of sight would be reduced to 0 because I already have line of sight. Okay, so that's something that I could do. These are considerations, right? So is the player detected? Yes or no. Do I have line of sight? Yes or no. What's the distance to the player? The distance to the player is too far, right? The player is the player within radius. Is the player's health less than 50%? This is like a float consideration. Less than. So it would be a less than float consideration, and so on. Okay. Okay, so I've got I've got this, and so I want to set utility and get utility. So I want to again, set utility, void set utility, which is like in a value, right? And that would be a float utility. And then get utility, which would be return a float, get utility. So that would be whatever the utility is that I would get. Okay. So far, so good. And in the constructor for the state, I could also set up not just the action state, but I can set up everything else too. So I can set up the action if I want, and the utility. I can do that all up here if I want to. So I can say that the action, right? So action is action. Now, notice I can't do this. I can't ask for an action here because actions only define inside the class. I would have to define this type definition outside of the class in the global namespace. And I don't want to do that, and that's why I can't do this. Okay? So for now, let's just keep it like this. I can define the action state, and that's it, in the constructor as an option, or not. Otherwise, it's no action state. And the utility is something that I can define or not later on. Okay? So now let's fix it up. And again, I can say generate definitions by declarations. These are all the things I can do. And make sure that the virtual destructor is still virtual. Sometimes they have a way of getting rid of that. I don't want that to happen. I can also make it so that I have some initialization. So m underscore action state, right, is equal to action state. Right? I can do that. I can also define action if I want to. So m underscore action. I can define that as null pointer because we're not pointing to anything at the beginning. As well as m underscore utility can be set to 0.0f by default. So I can set the utility to nothing at the beginning, right? Action state, you can see that it's a const. Whatever the const value is, that makes sense because I'm only going to set it once, right? Set action state, again, it would be m underscore action state is equal to state. And if I do that, that becomes a const. And set action, this is different. M underscore action is equal to action. So this is actually taking my action, which is a type definition for a function pointer, and I'm getting this one to point to the action that's being held in memory, right? And then perform action is going to say, well, m underscore action, just do that action. Whatever the action that's associated with it, just perform that action. This is going to be const, right? So I'm going to say whatever that is, perform the action that I've associated with this thing, whatever that action is. Set utility, so I'm going to say that m underscore utility is equal to utility. Again, this is going to be const. And get utility, I'm going to return m underscore utility. So just so I want to read the utility, I can do that. And I can return const here too. I can make this a const function, because that makes sense. Okay, so that is my state class. So some people get confused with this part. They're like, wait, this is a reference to the action callback, right? That's like that friendly pointer to the function. It's like a virtual function. I'm attaching a function to this thing by making it a function pointer. Right, that's what I'm doing. I'm saying, hey, this action here that I'm doing, this perform action, I'm going to perform the action that I've connected to this thing, whatever it is, right? So an example would be, I want to move to line of sight, right? Move to line of sight might be the state, right? Move to line of sight. But the action might be, find line of sight, kind of thing. It might be something else totally than that. Or it might be a function that's inside of the move to line of sight class. It's up to you. You can also define it on the fly this way too. If you want to do a different action from move to line of sight, slightly different every single time. You can also not have this perform action thing. The great thing about perform action is if I call it perform action, it would always, whatever this thing is pointing to, it'll call, which is good. And that means that anything that I define here as a state is going to have this perform action along with it, right? If that makes sense. Okay, so that is my state class. Okay, so I've got some building blocks, and now I can start building out the rest of my stuff. I can start sitting there and saying, okay, I want to make, and the first thing I recommend you do is do this line of sight, right? I want to be able to detect line of sight. How do I detect line of sight? And that would be something that is a consideration that not just my enemies would have, because my enemies wouldn't have detect line of sight or has line of sight, right? It would be each node would have a line of sight, right? Each node. And so again, how would I do that? Well, again, if I was to plan this thing, if I was going to do has line of sight, that consideration, I'm going to go back to my collision manager for a second. Let's take a look at my collision manager, and does it give us that capability? So in my collision manager.h, I have a couple of functions. One of them is this line check. Okay, I could do that, right? I mean, all I have to do is collide with one line, not even the whole line rect check, right? I just need to know which one I'm colliding with. And then there's this line rect check. This is perfect, this line rect check. So what does the line rect check do? Okay, well, what it does is basically do this. It says, okay, I want to take the line start and the line end, whatever that is. So kind of 2 points, the GLM vec2 and the GLM vec2. Okay, cool. And then I want to have the rect start, the rect width, and the rect height, or whatever the box looks like. Similar to what we did with the point rect check. And it's going to say this. It's going to say, okay, well, if the left line is going to do a line check between the left side of the rectangle and my line, right? The right side of the right, each of these things is different parts of the rectangle. The left side, the right side, these are the edges, if you will. Left edge, right edge, top edge, bottom edge. That's what those things are of the rectangle, right? So I can say if my left edge is true, so I've collided with my left edge, then return true. Or if my right edge, or if my top edge, or if my bottom edge, which means that when I go back to this, I say, okay, well, let's see this one. Is my top edge true? It is. It's colliding. How about my bottom edge? That's true too. But I only need one, either top or bottom, any of them, and it's colliding. It's hitting, right? So that's what's happening. If I collide with any one of them, I don't have line of sight, right? Why? Because that means that my line rect check is true. And if the line rect check is true, then there's no clear line of sight between that node and my player. Okay? So I could set up nodes. I could set up tiles. It really depends on how you want to set up your project. But again, if you look at it, a couple of things that I have in a game objects perspective is I have a bunch of tiles already. So my tiles, notice what I have here. Tiles have a bunch of things. I can know which tiles are around me. I can do pathfinding if I want to. This is already set up for you, so you could totally use this, right? The one thing that these tiles don't have, which I can add into the tile class, is line of sight with the player. And it can be done on some kind of update function, right? So maybe the tiles themselves don't update. Like I don't have an update function for the tiles, or do I? Let's take a look at that update function. So each update right now does nothing, right? So what I can do instead of nothing is I can check to see line of sight, and I can make it something that this thing has. Line of sight is each tile, right? So again, if you think about a grid of tiles, right? And if I was to separate this thing off here in a grid, if I kind of partition this in a grid, I can check for each tile, and if it has line of sight, if there's something blocking it, right? I can check between that tile, the center of each tile, and my player. Okay, that's what I can do. and then I have either a line of sight or I don't have line of sight. Okay. So does that make sense? So that's how I would do it. I would kind of put together a structure, either nodes or tiles or some way, some navigation, so I can move from one place to the next. Okay, and now I can't tell you which one to do because it really depends on your setup. I would probably set up nodes like this, and the reason for this is because then I know around my player, and again I'd have to map it out. I'm using here like a drawing program, Sketchbook, right? But what I probably want to do is I'm going to use tiles. I'd probably use Excel. And I've kind of shown you this tile example before where maybe what I would do is I would draw out the tiles, right? So let's say if I was going to remap this thing, you know, I would make sure that the tiles look like square tiles like this, right? And let's just make the entire thing white, right? And then I would start mapping. I would say, okay, well, I want tiles that are like, you know, from the top left corner, you know, again, 25 by 20. So something like here is 20, and I think it's 25 by 20. I think that's what I made it, or 20 by 15 or something like that. So there's 20, and then here's 15. So this is my map of my entire game board, right? Let's just suppose I made it this way, right? And then you can add in some spaces, right? So you can add in your spaces, and you can say that this is, you know, kind of the, you know, the columns, these are the rows as an example, and you could put in 0 here, and then you can say 1 and so on, and you can map it out, right, like so up to 19, and the same thing goes from here. We did this exercise before, right, where I kind of map all these out. So if you wanted to use tiles, you can do that instead. That's what I'm showing you. So we've already got that structure in place, so you can totally do it. So there's 1 to 14 and 0 to 19, and you can sit there and say, well, if I was going to remap this thing, the same picture I drew, for the most part, I could say that, okay, well, I want some kind of obstacle to be there, then let's make it so that there's a wall, 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 and these are impassable tiles, right? So wall, wall, wall there, and maybe there's a wall, wall, wall there, wall, 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 and then we made it so that the walls, this one here is got a strange kind of shape this way, and maybe another one that's up here. This is what I did, kind of. I'm just representing it in a different way. Okay, so there you go. So wall, wall, wall. And so now that I have this, when it's a tile map, and if my player was, let's say, here, this is my player, and this is my enemy, and let's say there's another enemy down here, is what I said, right? And there's another enemy up here, right? That's what kind of I mapped out. You can certainly do it this way. Or you can say, okay, does this have line of sight with this? Well, no, because if I drew a line that goes from here to here, you could clearly see that from here to here, it's going to, you know, go through this one, this one, this one. So you can still do the same checks, right? And what about when you want to find a place, a position that does not have line of sight? Well, this one, this one, this one, and this one now, in this case, none of these have line of sight. Now, because we're using a grid system, that means any of these ones, right? Well, maybe not this one, because this one is kind of diagonal, it goes right through here. But probably maybe this one and this one would have line of sight. And so you would check every single tile to see, you know, which one of them has line of sight with the player. You could do that every frame, right? And you wouldn't care about these ones, the ones that are marked with W, because those are walls. They're never going to have line of sight. The line of sight would always be false for those. Does that make sense? So you could definitely use a grid system as opposed to a node system, which is what I drew here. All right, node system, grid system. It's really up to you. Both, I think a grid system makes it nice and easy and compact. The great thing about a grid system is you can make it a radius of tiles. So you can say that the radius doesn't have to be circular. You can make it so that it's a radius of like square tiles around. So if it's within this block, you know, anything that's in this block at all, you would check that the player's in there, and then it can hear you, right? So again, if I said that the radius is like 3 blocks, so 1, 2, 3, 1, 2, 3, you know, 1, 2, 3, 1, 2, 3. Anything inside that radius, which would be something that looks like this, right? For this guy, I mean, he's not in hearing radius, right? If I said it's like 4 or 5 or 6, right? Still, you know, 1, 2, 3, 4, 5, 6. He is within radius. Once he's in within radius, so he's like something like this. So 1, 2, 3, 4, 5, 6. That's how big the radius, the hearing radius of these guys are. Then this guy would be within radius, but I can't see him, as an example. Okay. So that is kind of another way you could do it. You could do it so that detection, there's different ways of doing it. You can use the tile and grid system, and you can use the node system. Okay, depending on what you do, the first thing you should probably do is, can I see or hear the player? Yes or no? And if the answer is yes, then you can start taking actions, because that is basically where things start. And that's where I would start off. Okay, questions before we go, because we're kind of at the end. Anybody have questions? All right, I'm going to stop recording, and then if you guys want to, I'm going to hang out for a few minutes afterwards if you want to, ask me some questions. But for now, I'm just going to stop recording the YouTube stuff. So.